Welcome, everybody, to the DevStats session. Is that too loud? No, good. That's good? Okay. Welcome to the DevStats session. We are going to be talking about the system that is watching all of your development activity in Kubernetes. How many people here are Kubernetes contributors? Yeah, I got a whole bunch. So you're going to see your own stats here, although mostly not individually. These are mostly aggregate stats. We're going to have a bunch of people talking and exploring various parts of Kubernetes development through statistics. I'm Josh Berkus. Lucas is here, who's the lead developer in DevStats, and we have Elsie Phillips and Aaron Krickenberger and Tim Pepper, who are going to be showing you different charts and graphs that they use. Perhaps more importantly than people's company affiliations is their SIG affiliations, because that's the whole reason why we need these charts, is in order to answer questions that the various SIGs and other groups have. For example, one of the SIGs that I and several other people are involved with, one of the ones that Elsie co-leads is contributor experience, and they need to monitor community health, looking at how are we doing in terms of people contributing to Kubernetes and how the results are and everything else. I'm on the release team. The release team needs to try to anticipate blockers before they delay a release by looking at development stats. The steering committee wants to look at some of the stats about how developers are doing things in order to get an idea how policy changes and changes to the way that we do things would affect our developers. And the folks at the CNCF want to advertise how well Kubernetes is doing and how big and how fast it is moving as a project. So we have all of these purposes for which we want developer stats. And some of the questions that we want to answer are questions like, for example, who is contributing to Kubernetes? Like, what companies are they from? What regions are they from? What types of contributions are different people making and that sort of thing? Who's doing the most code reviews is another question that comes up, particularly because we do shout outs and other things to people who are doing code reviews because that's really important. Which SIGs have the most issues? Which employers are contributing? Because, companies who join the CNCF and start contributing to Kubernetes make big noises about stuff, and some of them contribute a whole lot to Kubernetes and some of them maybe don't. So, and then we also want to answer some what questions, some content questions, like what's going on right now in development activity, or what is the label that we've got a whole bunch of PRs hung on, or how many issues are being filed against each repository. And all of this is time-based as well. So we want to answer other questions, like for community health, we want to look at, hey, when does an issue first get a response from a real person on average? Or how long does it take to merge a PR? Or when are busy periods as opposed to our slow periods? And do those match up with our expectations? Now, if you've used GitHub from other projects and that sort of thing, you know GitHub has stats, right? There's some stats available in GitHub. There's a few more available through the API and that sort of thing. And they've got some stuff of, we have this many commits and we merge this many pull requests and that sort of thing. And that's more or less what we're using at first, and you still see some people reporting the GitHub stats. But these are really not all that useful for a variety of reasons. The first being that there aren't a lot of stats available, period, right? We've got commits, maybe issues. We've got this one stat called traffic that's kind of a grab bag for everything that anybody does. We can't report on things based on labels, and we use labeling of PRs and issues extensively to categorize them. In terms of contributor activity, in terms of like picking out individuals, GitHub will only show us the top contributors, and we can't actually get out all the contributors or characterize them. And then the timescales with the default GitHub stats are just really not very configurable. As in, you can get like a week or a month back for a limited amount of time, and that's about it. So really not enough data for us to answer any of the questions that we want to answer. Further, Kubernetes as a project makes this even more difficult because we have some peculiarities compared to like a small team GitHub project. For example, most of our traffic on all of our repos is from bots, but we don't want to count that because it's automated traffic. Everything gets merged and stuff doesn't get committed directly to the repos, or at least it's not supposed to be. And also we have this weird thing where we need to aggregate groups of repos and bind repositories together in order to see them in a way that represents the different sort of development areas of the project. So, last year, the Cloud Native Computing Foundation funded a project. I hired Łukasz to work on it. Started July of last year. In order to develop a platform for looking at a much richer and more in-depth set of stats and development activity on GitHub and presenting it in better visualizations. Now, this is still a work in progress. We are constantly changing around and adding new graphs and consolidating graphs and renaming things as we find out which things are actually useful. But we're going to show you a few right now that people have used in their particular SIGs and in their work as examples of where you can use these developer stats to see things in the Kubernetes project. So first of all, Elsie Phillips from Contribute Experience is going to talk about PR time to engagement.
Okay, test. Great. All right, so this first graph that we're going to talk about is PR time to engagement. And what this essentially is how long does it take for somebody who isn't the author of the PR how long does it take for that PR to get any engagement? And so we can use this graph in a couple of different ways. So right now we're looking at the across all of the repositories, across all time as well. And so we can actually drill this down to specific repository groups. And why this graph is useful is it can tell you how responsive people are to the pull requests being made in individual repositories. And so we can go down here and we can see the breakdown, the 85th percentile, the median, and if we scroll down a little bit, Josh, could you scroll down for me? The 15th percentile as well. And so we can see across all time these stats over here. So we can see for the 15th percentile, our average time is just a little under an hour, which I think is actually pretty great. And so we can see that over time how responsive we're being.
Okay. Well, thank you. Oops, actually, let me stick to mine, not double it. Thank you very much. And by the way, if any of you actually have laptops out and you want to follow along, this is all live, and so you can actually follow along. What you want to do is go to k8s.devstats.cncf.io. Sorry, I don't have any way to enlarge the URL there. But look up Kubernetes DevStats is the other way is to search on them. And then you scroll down to the list of charts. We are still in the process of cleaning up this list of charts in terms of having very informative names for things and consolidating some charts and that sort of thing. But we've done a lot of that already. And so then you can actually look at some of these and manipulate the parameters of them yourself, including timescales, repositories, and other things. So to show you another useful chart, Aaron from SIG Testing is going to talk about bot commands.
Hi, I'm Aaron Krickenberger. So yeah, although steering committee was next to my name, I'm here more in a capacity as a SIG testing lead. This this graph shows all of the usages of /bot commands that people can use to interact with our automation throughout the project. I gave a talk earlier this morning talking about how we enable like people who aren't members of the project to add labels to help triage issues. People who are members of the project can be assigned to, can /LGTM to signify that they've reviewed a PR, approved it, so on and so forth. So I wanted to show a couple things that this graph helps me learn in terms of, are people actually using our stuff? Are we actually doing a good job of communicating this stuff? So here I'm looking at every single bot command ever, and it's sorted by most usage. So we can tell that most people, instead of like using GitHub's drop-down box to assign people, like just typing /assign and then a person's name. It's by far the most popular command. The next one, CC, is for requesting a review from people. So it's mainly about like delegating between people, right? The next most interesting thing to me is we issued a command called retest, or we instituted a command called retest about the same time last year, where if any of the 12 tests that runs against your pull request failed for whatever reason, and you wanted to rerun those tests to see if it was a true failure or just like an environmental flake, instead of selecting each individual test, you could just hit /retest and it would run all the tests that had failed. Initially, there's this really large spike because it turned out to be hugely useful and very popular. Over time, it's gone down because we now have a bot that looks for pull requests that have been approved and reviewed by humans, so they have the appropriate labels. They're just not passing tests. And so we can have the bot spam /retest. It's also a really good proxy for like what's the relative stability of the project over time. As it goes up, that's probably a sign that there's either more traffic or that our tests are flaky and we should do something about that. Finally, these little dashed red lines here, maybe it's tough to see, indicate when a release of Kubernetes was cut. And if you look at these huge spikes before, these are times when people issued the /approve command. So /approve is what somebody who has like the final say on code uses to say, yes, this code is valid, it's doing the right thing in the right way. And you can kind of tell when code freeze is happening throughout our release process because everybody's rushing to get those approvals in before code freeze happens. It's kind of telling me also that there's a lull afterwards. You can see here the nice KubeCon dip from last year, where it'd be great if we could find a way to make our release process less sort of herky-jerky, a little smoother instead of having people constantly rush for this. But anyway, those are all sorts of insights I can view. And this is the sort of stuff that I can't get by looking at Git. I can't get it by looking at GitHub. We really needed some specialized scraping of GitHub comments to see how people are interacting with their automation. Thanks.
Thank you. Okay. Shrink this a little bit. Okay, so next up, we're going to have Tim Pepper with issues open closed by SIG, and I think this is from your work on the release team.
Yeah. Do you have the slide version?
I do have the slide. I do have the slide version. So,
Perfect.
Yep.
So there's the shareable URL. I don't expect any of you to copy that down, but if you're looking at the issues open and closed, specifically you can, if you're looking at the issues open and closed by SIG, you can tunnel in specifically to feature type. And this kind of follows on to what Aaron was showing. So even though SIG VMware was next to my name, I'm actually here thinking more with a sig-release and also a bit of contributor experience perspective. So the red lines are a little easier to see maybe here. These are the release points. And Aaron was talking about the phases where code freeze happens. But I'm curious about when feature freeze happens. So issues themselves fall into two course categories. There's bugs and there's features. And we're talking on the release team about shortening the period of feature freeze to allow more smooth development and maybe get some of the less herky-jerky that Aaron mentioned. But I was curious, well, what's our volume of feature open and close? Does it have a normal sort of S-curve sort of feel, or what? And this is what I see. And the red arrows that are sort of hand-drawn on there are the period, are the point at time of the feature freeze. So it got me wondering, well, what is this other stuff? Is it late features? Are people kind of gaming the system? Are we not noticing what's going on? So then I went to looking, instead of at the 7-day moving average, just to the day perspective, and comparing just the opens and the close, you actually see that more or less we kind of have a steady state. People are kind of always doing feature development. And to me this makes sense. This is open source. Like we get an idea, we work on it. Now, the big question that I'd like to see, and I got to open a PR against Lucas on this to get an enhancement, is in the middle of this, could we overlay the actual label or milestone? And do we see that these spikes are people getting ideas that are going to be in the next release, or are they late things in the current release? And then with that little bit of additional information, I think we could do a little better risk management on the release team and understand whether we're missing something here or whether it is actually safe to shrink the window down some. So that was just something I was looking at.
Thank you. Okay. And the last one is mine, and this is from, I've been on the release team for several cycles. This one was actually one that I developed I developed by submitting an issue to Lucas. Around 1.9 because I was tracking the various PRs for 1.9. And there were a lot of PRs that were not receiving attention from SIG-node specifically. And so I was like, okay, so is this that the SIG-node leads are just AWOL? Or is it that SIG-node is getting a whole ton of stuff thrown at them and they can't keep up? And for that matter, could we detect this in the future before it becomes a crisis during code freeze time? To say who is heavily loaded. Now, this exists in a couple of times. This is, PR workload push sig as a graph. And you can look at sort of the general graph. And let's not do last 6 months here. Let's do, say, last 30 days. And so you can actually look at this as sort of a general graph, and you can kind of see what's going on in general, because in terms of sort of PR activity, and we have the sort of slow growth of open PRs. So by the way, this one particularly, because we're looking at workload per sig, we specifically are looking at all open PRs, not just recently open PRs, because some old PRs are actually the biggest work generators because they've been open for a long time, because they represent things that are hard to get right. And this gives us an idea of general, but really what we want to know is which SIGs right now are hotspots, which ones are general problems, and which ones are likely to be problems. And so for that, we actually have a numerical chart, which tells us a little bit more. So like, for example, and like I said, everything here has configurable timescales and different things. So for general, like when I was actually looking at this for 1.9, come on. Scroll down. So let's look at this in the 1.9 development period. And we look at this in the 1.9 development period, we can see which SIGs actually have a lot of open PRs going on. Now, one of my goals with this is to create what people so I come from the world of like hardware performance networks, metrics, et cetera, prior to working with Kubernetes, database engineer and that sort of thing. And so I was trying to construct here what's called a second order metric, which is where we synthesize several raw numbers in order to give us sort of an intelligent assessment of a condition by putting those numbers together. So in this case, we're putting several things together. We're putting the number of PRs, which is this first column, together. Putting the number of PRs together. And here, we're multiplying the number of PRs by a factor according to the size label that's applied by the bot. That's an estimate of how big that PR is. And then we are dividing that by the number of active reviewers So you can get an idea of what the sort of workload is per reviewer in that SIG. Because a SIG that has a moderate number of PRs but only has one currently active reviewer is obviously going to be more heavily loaded than one that even has a high number of PRs if they have 10 active reviewers. And you could see during this period for the 1.9 period that indeed SIG node was really busy, although was not actually the busiest SIG for the whole 1.9 cycle. And so it was a combination of busyness and leads not being responsive. And so I harassed the leads to be a little bit more responsive and things got a bit better. But, for then we can actually then go and look at this, say for the last 10 days period. And there is a problem with this. I told you it was still under development, and there's a problem with this in that SIGs that have very low numbers produce weird factors for relative PR workload because they don't actually have a lot of PRs, but they have very few reviewers because it's just small workload in general. So ignore the ones that have one columns and look at the ones that have more moderate amounts. And so like looking here, and for example, if I'm looking for what is potentially going to be a problem SIG in terms of workflow for 1.11, one of the first things I'm going to look at here is API machinery, for example. But also potentially SIG CLI, because even though they don't have as many PRs, they also don't have as many approvers. So, with that, so that's a few of the things that we explored. So every one of these sort of charts within DevStats is there to answer certain questions. Some of them are a little bit more general, like we have a general compilement of the GitHub stats by various indexes, because that data is available and somebody might want it someday. But a lot of the more sophisticated charts are there to answer a particular question around Kubernetes development. So, having explored the charts a little, then we want to actually talk a little bit about how they actually work, partly to help you understand the data that's being displayed. So Lucas, do you want to come up and talk about DevStats, the project, because of course it is an open source project as well.
Okay, so I will just tell a few details about implementation. Here's a GitHub page, CNCF DevStats. It's on Apache license, and it's written mostly in Go and a bunch of shell scripts. This is a big data flow picture. Actually, the Kubernetes is not the only project that uses DevStats. Every CNCF project has its own dashboards. So there are three data sources: GitHub Archives, Git, and GitHub API. And the remaining part, which are Postgres database, Influx database, and Grafana, is actually duplicated 20 times because every single CNCF project has its own instance of this. We choose GitHub Archives instead of some other alternatives like BigQuery or, for example, GitHub Webhooks or other such things. The advantages of GitHub Archives are that we can have full historical archives for every event from the past, and every such event contains its state from the past, not now. GitHub Archives is free with no rate limits, and it's available on GitHub-archive.org. They are releasing every single event that happened on GitHub during the given hour. All the events are packed into multi-JSON array, and this which is zipped. We are just downloading this every hour. Filter are non-Kubernetes events, or for example, non-Prometheus for Prometheus and so on. We are putting all the results in the Postgres database where we have a full historical state of every single event. Next, we need a data source Git. It's used for one single purpose. When we are defining repository groups that are something like projects, for example, Kubernetes can have few repos. Test infra can contain other repos and so on. We are also analyzing files modified in the given Git commit. So we can define a repository group as being a set of GitHub repos, and additionally some paths and files from the other repos. So this is why we are using Git, just to get a list of modified, add, deleted files from each commit. Here, exactly. This is like, for example, we can define something like kubeadmin, which is a kubeadmin repo, plus cmd kubeadmin from Kubernetes, for example. And finally, we are using GitHub API source. One may ask that we can use this for everything, but it's rate limited. We have 5,000 points per hour, which is way too low to get data we need. We can't get past state of the objects from GitHub API. And also, it's quite slow. Generating all data for Kubernetes for 4 years of activity takes about 2 hours, while my estimate to get this data using GitHub API is about 3 months and more, because because every single request must be made as a HTTP call to the web service, and that requires sending JSON and receiving JSON, and it's basically slow. Why do we need GitHub API? There is a problem specific for Kubernetes, because if anybody wants to add a label, it cannot be done directly. The one must issue comment to the bot, like label something or so on. And in that case, the bot is adding label. So the problem is that when a bot adds label or modifies, for example, milestone, there is no GitHub event generated in this process. So when we are, so the result is that we have a final state from the issue with the old label set and old milestone before the bot applied the changes. And for example, few dashboards that were analyzing data for the releases like 1.9 and so on were getting wrong state of the objects, because we will have the correct state of the labels or milestone only after the next GitHub activity, which may happen, for example, after the month. So the final state is wrong, and we are using GitHub API only to query the recently modified issues and PRs from the last 2 hours, for example, and only to get a final state of the label set and about the milestone of those issues. Well, another databases. As I said, PostgreSQL holds a copy of our historical GitHub data. InfluxDB is used solely for display time series. So it's a data source for Grafana that is finally used for displaying data. We are using 2 databases because calculating Postgres metrics is very complex for some of the metrics. For example, it can take minutes or even more. So we are processing all the metrics every hour and saving final results to the Influx database, time series. And those Influx time series are very simple. They only contain data that need to be displayed by the Grafana. So the final process is fast and doesn't require any expensive computation. Finally, we are using Grafana. In reality, we are using 20 Grafana instances that are selected by the Apache reverse proxy based on the server name. So you can use K8's DevStats, CNCF IO, and you will get Kubernetes Grafana. But you can use, for example, Prometheus DevStats, CNCF IO, and then you will get Prometheus Grafana, and so on. Also, we've developed a small tool to mass import JSONs and modify them, because doing this from the UI is just not applicable, slow, and cannot be automated. If you want to contribute to the DevStats, you can create issues and PRs on the GitHub repo. But if you want to create new charts and request, there is another way.
Yes. Yep, so Elsie, you want to come up and explain how to request new charts?
Okay, so you have a great idea for a new chart or another request. So go to that link right there, and I'm sure Josh will have his slides posted as well. This is the process. So you create a card in the GitHub project with your proposal, with that information, and then you wait for the DevStats subcommittee to review it. We meet every week. It should be pretty fast. If it's approved, then it'll be moved into the approved column, and then it'll be made into an issue and assigned to Lucas. And if it isn't, there'll be a thorough explanation of why it wasn't approved in your card. And that's the project, and that's the process.
Okay. Well, thank you. So that's a little bit of a tour of DevStats and information about Kubernetes development. We have about 5 minutes for questions, which could include both questions about DevStats and the architecture and the contents, or you could just lob Kubernetes development information questions at me, and I can try to dig through DevStats to see if we can answer those.
Can you upsell the other session?
Wait, what's the other session?
Isn't there a deep dive?
No.
Sorry.
Nope. There isn't a deep side. So no, I can't, is the answer. Or I'd have to do a lot of upselling. Yes? The question was, can you take us through an instance where you use this to answer a solid question that you remember? We did a little bit of that earlier. Like I was showing, for example, the business about PR workload and trying to figure out which SIGs were heavily loaded so that the release team could target those. And Tim showed us looking at what we were looking at in terms of issue backlog. And answering those questions.
And actually, a few numbers from the keynotes came from this system. So.
It's a different one. So I'll answer for me. What we do in response to that information was, for example, on 1.9, we were looking at, here we go. Let's go back to the actual time zone for the 1.9 development, because I realized that, I had realized that SIG-node was probably heavily loaded, but it had not occurred to me that SIG API machinery was heavily loaded, let alone SIG CLI. And I actually, in that case, actually jumped into those two SIGs and I said, by the way, you guys have a lot of open PRs right now. Do you need help? And in the case of SIG CLI, the answer was actually yes. And so I got one of the Kubernetes founders to help them out with clearing out PRs. Like I said, right now we're sort of in the transition because we're developing this sort of transition of moving this from, say, sort of first order stats that are like a metric to sort of second order stats that are more directly actionable as we figure out what those are. You want to give?
I have a technical question for Lucas.
Okay.
Related to second order stats.
Yeah, so you want to answer this?
Yeah. Computing second order stats is really, it would be great if we could do that within Grafana itself, right? So one of the limitations of the InfluxDB data sources is that I can pretty much only get time series from it. I can't add two time series together or subtract them or do any kind of comparison whatsoever. Graphite, I totally can. I'm not sure if Graphite's the right thing here, but I'm wondering if there's some other data source we could use instead of InfluxDB that would allow us to do some of those second order things.
Well, there is such a data source. I was taking into account the Prometheus. And I actually have a green light to do some initial research about how it will behave. Do we have everything we need? And probably if that will work for us, we will just add Prometheus as a time series, as an alternate source of data.
Cool. More questions? We can take one more. Okay, well, like I said, this is live. It's available online to anybody, no login required. So please explore the stats yourself. and maybe ask some questions based on what you see. So thanks for coming.